Hi and welcome back. So the first category of receptors is the GPCRs, and GPCR just stands for G protein. Should have capitalized that. G protein coupled receptor. So they're named so because they activate G proteins. Okay. They are probably, I think, from what I remember, they are the largest family of receptors, and they contain 7 transmembrane helices. And if you have your CARP textbook, there's a really cool picture of it, illustrating the 7 helices. So you might want to take a look at that. So these translate. So you have your, I'm just gonna randomly draw. So 1, 2, 3, 4, 5, 6, 7. Obviously, they don't look anything like this, but what these receptors do. So you have your ligand binding onto the receptor. They translate the signal into activation of G proteins. Okay. So that's all the briefing that I want to do for G proteins. The second kind of your receptors is the receptor tyrosine kinases. No, don't like green. Let's use red this time. Okay. Receptor tyrosine kinases. Receptor protein tyrosine kinases. This is a second class of receptors that have evolved to translate the presence of the extracellular messenger molecules into changes inside the cell. That's very generalized. Binding of specific extracellular ligand to RTK usually results in receptor dimerization. That's the important point here. The receptor dimerizes when the ligand binds to it, followed by the activation of receptors protein kinase activity. Now, just from the name, because it says receptor protein tyrosine kinase, it means it has kinase activity. So this receptor dimerization is followed by the activation of the kinase activity. That means this receptor can now phosphorylate. Kinase activity, i.e. receptor can phosphorylate. Okay. Upon activation, these protein kinases phosphorylate cytoplasmic substrate proteins. So what kind of things do they phosphorylate? So because the signal is transmitted inside the cell, they phosphorylate cytoplasmic proteins. Okay, and that would change their activity in some way. Obviously, that's what protein modifications do. So it changes their activity in some way, their localization. So remember that video that we did about the 4 things that can happen. So this is sort of like a review. So it can change the location, can change the activity. What were the other 2 things? It can change, trying to think, interaction, yep, with other proteins, and yeah, within the cell. There's one more thing. Let me just go back to it and quickly review that part. The degradation part, so you can put that as well. Degradation. Alright. So those are the things that can be done at this point. The next kind is the ligand-gated channels, and these are pretty cool. I kind of like them. Ligand-gated channels, and I think you do talk about them, well, at least we did, in neurophysiology unit, in a physiology class. Now, ligand-gated channels are cell surface receptors that bind to extracellular ligands. Their ability to conduct, so that's the key point, they have the ability to conduct a flow of ions across the plasma membrane, alright, is regulated directly by ligand binding. So you have a ligand, binding to the receptor, and this will allow ions to just flow into, and this is plasma membrane, ions to just flow through. Well, we have 3 seconds left, so I'll continue this in the next video.